Let us now turn to Chapter 2, Weapons, Autonomy, and Artificial Intelligence. The author starts out by pointing out, some dangers. One of the things that's going to be very dangerous with autonomous weapons is what we all know about computers. Anytime you have a machine that's out there in some sense, that's connected beyond your immediate control, it's liable, susceptible, in danger of being hacked. Right, and that's been a big concern with all kinds of autonomous devices, from whether they're your computer that's hooked up to the internet and interacting with the internet in ways that you're not always aware of, but it's on and it's engaging. Your cell phone is always engaging with Wi-Fi or the internet in some way, and of course it's liable, susceptible to being hacked. And of course, if your car is online, there's always those fears of someone could manipulate the software and cause all kinds of horrific consequences. And also, limited bandwidth if you had a number of machines trying to communicate. These are, some people say, are inherent technical problems that's just, that's always been a problem in warfare, and that's been communication. And so they could be countered. If you had a bunch of very sophisticated machines that were operating and communicating wirelessly, it wouldn't be that hard to rig up jamming devices. So you could end up spending a lot of money and time to develop machines that could be actually very efficiently rendered inoperative by some very primitive jamming devices. So someone doesn't have to necessarily destroy the machine. They just have to destroy its means of communication and basically take it offline and render it inert. So there's all kinds of problems that would be classified as technical problems. In this chapter, there's a discussion of the question of autonomy. So and we've seen this in previous videos. Coker talks about this, that machines won't really achieve autonomy. Searle talks about them not really being self-conscious and aware and having a sense of self, and so wouldn't really be autonomous. They're just they're automatons, but they're not autonomous. So be careful about the distinction between those words. Well, autonomy is not necessarily like a complete autonomy, but like a machine autonomy, and it comes in different levels. So, we want to, have them be a bit more nuanced. And so there's these three levels: pre-programmed, limited, second limited, supervised autonomy, and then, a complete sense of autonomy. And again, it's an ambiguous term. That is, autonomy can be ambiguous because it's often used in different ways. So what's this sort of machine autonomy, low-level, pre-programmed? There's very little variance here. But again, it can be really autonomous in one sense, like something as simple that doesn't have very much variance. It relies on pre-programming. Might be something like like just a simple bomb that's triggered, right? When it's stepped on or whatever. That is a device that's autonomous. You don't have to monitor it. It will do its job all on its own. It's not, but so in that sense, it doesn't need input directly from a controller. It's just set up and left to, but it doesn't have much of a variance. It has to be triggered in a very certain way. So it's only got a very limited, and it can't do anything but explode. Right. So, and it can't discriminate whether it's an enemy soldier or an ally, or just an unfortunate animal that happens to be running across it, or a civilian or whatnot. So their full-fledged autonomy is one of the biggest problems about them, and it's certainly nothing to be admired. And it's cheap, and so that's been a huge problem. So you can think of autonomy in that sense of like completely independent, but that's not really the kind of autonomy that we're talking about. That's a very low level type of autonomy. So smart bombs that have some limited amounts of autonomy, mines, cruise missiles, things of the like. And a non-military autonomy would be like a painting robot on a factory line, right? That you watch them, they're fascinating. You watch how fast they are, but they don't really do very much. And what they do is extremely fast. They do it very well, but they paint certain parts, and so they're pre-programmed. And then the part comes in, and then they move it around, spray paint it, and fire it down to another robot that maybe does something else with it. So that's a very low-level pre-programmed kind of a canned sort of technology. The next one up Limited supervised autonomy is a much greater variance, right? So, much more variance, and, because again, the painting robots, the landmines, there's very little variance in what kind of input, right? So it's either a pressure point or some kind of object comes in that they recognize and they can manipulate and perform an action on. This limited would be, or supervised autonomy, it would be a much greater variance in what sort of inputs can come in. But in the end, it's still going to be maybe even less reliant, more reliant on humans. So it might have more of, so we say, the input autonomy. It can handle more different things coming in than painting robots can. But its outcomes are going to be somewhat more governed by the human that's in the process or the chain, whatever image you wish to use. So the big issues, so to speak, the humans would be involved. And then, of course, the last one is where it's not just sort of the front end autonomy, where it's got a wide variance in what can come in, right? Like the second one, but it's also like the first one in that it just does its job on its own without a human coming in. So it's like the front end variance and the back end consequences. It's all autonomous. And in that sense, that's what we're talking about now with a more complete autonomy. And this would be, there's no need for human input in any part of the event, of the incoming data or object, and the consequences that ensue or that follow. So the humans aren't part of this story at all. Also, with this complete sense of autonomy, think about it. It's as we talk about ourselves. When are you really autonomous? Well, yeah, when you're self-supporting and and all that kind of stuff. But it's also when you make your own decisions, and you learn from your decisions. You don't just keep doing the same thing over again and expecting a different result or whatever. To learn is to see that, oh, well, I got to try something different. If I have the same data coming in and what I did last time didn't work, same situation, I'm going to try something different. And you start reasoning on what you did and all that kind of stuff. That's the ability to learn. So now we talk about, as Turing did, like the notion of machine learning. That would be a huge advance. And we do have machines that now can learn. And also, what seems to be, increasingly relevant is machines that can fix themselves, right? So in a way, like machine healing, right? You get a cut in your arm, and if it's not too serious, it just heals, right? And then if it's more serious, we've got other humans that help, doctors and nurses and whatnot. We fix ourselves, so no one swoops in from the outside. We do it ourselves, so that there would be, kind of a notion of medicine for robots that they would administer themselves. Either they fix themselves, and if they can't fix themselves, they would fix each other. There would be robots that would have the ability to fix and repair other robots. And so this would be now where these entities, whatever you want to call them, these machines are developing a more complete set of autonomy. Now, this is sort of a number of ways you can organize this concept of autonomy with all its sub-levels. And I just mentioned, sort of an incoming autonomy and a consequential sort of autonomy. You can have a look at some tables that the author set up on pages 45 to 6, trying to put some order on a lot of these concepts and how this might all fit together. So you can get an overview. So it's a good thing to have a look at that. Now, in addition to this bit on autonomy, the author goes over some history of AI. We've seen this in our lectures and videos on Turing, and then on Searle. So, but you can get a little bit more here in some of the ideas that we've already seen, and a few different directions as well. But an important distinction that's made in the history of AI, which we haven't really seen, is the notion of top-down versus bottom-up. Turing alludes to this. And the notion of top-down sometimes is like old-fashioned approaches, and the bottom-up is sort of a newfangled approach. There's a simpler way to think of all this. You can get into a lot of technical stuff with it, which is fine, but I'm not going to do that here. Is the top-down approach was, that you would have a kind of a fantastically complicated computer program that would be mimicking us, and then you'd feed it in the information. So you spend all your time doing this great program, you feed it in, and then boom, you've got this sort of entity that comes out that you would say is some kind of maybe not sentient, but certainly some kind of autonomous creature. Now, this approach, this top-down approach by programming, then putting data in, has run into troubles. The author goes through a number of the difficulties. Doesn't seem to really work all that well. That was the initial move. Go back and have a look at the Searle sections. He talks a lot about that program, how excited everybody was when they figured that they could sort of map all this out in advance. Just get your programming right, and then we'll feed the data in and we're done. Doesn't seem that that's going to be the right approach. Kind of in the sense of if you want people to learn, we sometimes say, hey, put the books away. You don't want to learn stuff, you're going to learn it through experience, right? You're not going to learn about the world by reading about it and getting your information that way. So there is an analog to our own experience of how are you going to teach your kids stuff? Well, sometimes they got to go out and learn it on their own. That's, experience is the best teacher. It's a pretty harsh teacher too, but a lot of the times when you learn something through experience, you really learn it. So like hands-on learning. Well, why not apply that in artificial intelligence as well? That's a bottom-up approach, right? So yeah, you might put a program, a fairly sophisticated program in, but you're also going to try and get the program in some kind of instantiation where it's some kind of quote-unquote body that's in the world and has to react to it, and it learns that way. So rather than trying to just download all the information into it, like just reading a book and learning about it, no, you're going to give some information, hopefully the tools that the entity in question, the AI, will need, and then it's off and it's going to go learn. And in that sense, it's not controlled by a kind of feed from a human programmer. It's basically, the feed is the world. And there are a variety of methods in this. And the author goes into, different ways of approaching a bottom-up. But the two are two very different, and, sometimes people try to combine them for certain tasks. So there are some tasks, that you learn as a person, as a regular old human being in a top-down kind of fashion. And there are some things that you learn bottom up, and Aristotle recognized this. Even this distinction of learning, as in a top-down or a bottom-up fashion, that's nothing new. So the idea of it being nothing new for us, it's new to think of it as, training machines in these different ways. So you're going to have a look at the more details in the in this chapter in Krishna's book. All right, now. And so the people say that are in favor of the bottom up, saying, you just get, with top down stuff, you really just get zombie machines, right? You don't get real interactive units or maybe creatures or whatever you want to call them through this top down. It has to be bottom up. All right. Now I'm just going to end on what Krishna mentions is this little story by Aldous Budry called The First Serve. And he points out a dilemma of robots. Build them too smart, they're dangerous. Build them not very smart, and what do you get? You get useless. So how do you construct some kind of artificial intelligence that runs in between the dangerous, useless problem? And so which is the way to go? But that, of course, that'll be a story for another video. In chapter 3, just as a brief mention, but I'm not going to go into that. You can have a look at that in more detail. That's an overview of the various systems in development, the various military type programs, and the systems are there. Not a lot of discussions of ethics in there, more of just some nuts and bolts stuff. Have a look at that. But again, the only problem with some of these is that's from about 2009. So, given where we are in time right now, it's a little bit dated. But the philosophical issues are not dated. They're still there, if not even more intense. And so we'll carry on in the next videos to start looking at these more intense philosophical and ethical issues involving robotics and the military.